Today I'm going to describe the hardware power management features of the Oracle T4 system. The system I'm using has 4 SPARC-T4 processors and 256 gigabytes of memory. Each processor has 8 cores, and each core has 8 hardware strands. The system is managed by the Oracle VM Server for SPARC version 2.2. It's also known as the LDOMS Manager. And I'll show you that, the version we're running. The system has one logical domain which is running Solaris 10. The domain is configured to use all 256 of the strands and all of the memory. I'll show you that. So we have one domain here, 256 CPUs and a whole bunch of memory. And we can see the domain, the OS that's running, which is Solaris 10. I've started a workload which is fully loading the processors. You can see that here in this graph. This graph shows when the CPUs are busy, the bar for that CPU is green, so you see the CPUs are basically all 100% busy pretty much all of the time. Now let me just, I just wanted to show you here we have the power consumption of the system shown in this graph. So you see the system's using about 1400 watts, a little less, maybe 1350. Now let me pause the load. And you see the load has gone down. Now all of the CPUs are basically all idle except for a little blip here or there. And the power consumption goes down to about 1150 watts. Now you can also see the power consumption of the system through the service processor. Over here I'm looking at the ILOM Integrated Lights Out Manager, or ILOM, browser user interface. If I take a look at the Power Management tab and the Power Consumption sub-tab, it'll show the power consumption of the system. That was the power consumption when the load was running, and then you see here the power consumption when the load is idle is about 1150 watts. You can also see some additional statistics related to power consumption. Here we have a rolling average for the last 15, 30, or 60 seconds of power consumption. And you can also see the power consumption history. Here we have the last hour's worth of 1 minute averages. That's the average across that hour of 1 minute averages. And here we have 1 hour averages averaged across the last 14 days. But mostly what I wanted to show you today is the power management controls that are available via ILOM. First we have the power management policy. We have a choice of 2 policies, performance and elastic. Right now we're running in the performance policy. In the performance policy, all components run at full speed or capacity. So what that means is even if the system is idle, as it is now, or even if the components aren't assigned to the domain, the components all run at full speed. The other option we have is the elastic policy. Now if I were to apply the elastic policy, which I'll do in a minute, you'll see that what elastic policy will do is this policy is communicated to the LDOMS Manager. And the LDOMS Manager monitors the usage of the hardware components, and when they are not being used, when they're basically idle, it'll put those components into a low power state. On the T4 system, we have a couple of hardware power savings features. First of all, let's talk about the processors. The T4 chip supports cycle skipping. The chip can be configured to skip up to half of its clock cycles in 1/8 increments. So this graph here shows you the speed at which the processor is running. Right now all of the processors are running at 100% because we're in the performance policy. If it were reduced, then these bars would go down to 50% here. The other feature that we have here is power savings on the memory. On this system we have 8 memory segments. These are each regions of memory that are interleaved. And we can put each of these regions into a power save mode. This is a hardware power savings mode where the hardware notices whether the memory is being accessed. If the memory is not being accessed, it will put the memory into a low power state. As soon as a single access comes in, it awakens up the memory, and that memory is then available at full speed for all the remaining accesses. So when the LDOMS Manager sees that a region of memory is not being used very much, it puts it into the power save mode. If it sees the memory is being used a lot, it ensures that we never go into this lower power state, and so the memory is always at full speed access. So let me apply the elastic policy, and you see the elastic policy gets sent over to the LDOMS manager. The LDOMS manager sees that there's no activity on the system. It puts the processors into a low speed, 50% speed, and it also puts all of the memory into the power save mode. So when all that happens, we save about 200 watts of power here. So when you're in the elastic policy and there's no activity on the system, it's an idle system, we save about 17% of the power that you would use if using the performance policy on an idle system. Now we have one other power savings feature on the system, and that's the ability to actually turn off cores. Cores can't be turned off if the strands on the cores are being used by a domain. So here all 256 strands are owned by this domain, and Solaris can make use of any of those strands whenever it wants. But if we knew the system were going to be idle for a while, we could remove some of the strands from the domain. So I will remove all but 64 strands from the domain. So the LDOMS manager removes strands from the domain, and because we're in elastic policy, it sees that some of the cores aren't being used, so it turns off those cores. Now, one of the other nice things about the LDOMS manager is that it tries to pack strands into cores, and you see here that all 64 of these strands are just on these cores, and not only that, but the cores are all in a single processor. So that means these other three processors are basically not being used. We have to keep one core on per processor to handle interrupts that might be being needed by the hypervisor. But other than that, the processors are not being used. We can go further, and we can actually remove all but 8 strands. We could remove even more than 8 strands, but it doesn't save any additional power. But again, because the LDOMS manager packs strands onto cores when adding or removing strands, here we end up with a single core being used, and all of the rest of the cores are not being used and can be put into the off state. So once we've done all that, we save an additional 50 watts of power here. So now we're running at about 900 watts. Let me just show you that here. Here we see that the power consumption is at about 900 watts. And so that's about a 22% power savings from running in the performance policy in this same state. So then the next question is, well, what happens when a load appears? So let me just add these CPUs back into the system, and let me restart the load that I had paused. So you see the load starts loading everything up, all the CPUs, and the LDOMS manager sees that the load has reappeared and puts the processors all back to 100% performance, 100% speed. In this load doesn't have much of a memory load, so the memory remains in the lower power state and just the processors are put into the high power state. And then you see, of course, the power consumption goes back up because we are now providing full performance to this workload. And maybe a little bit less than before because we didn't have to put the memory into a high power state, and it's probably being powered off now and again when it's not being used at all. So we see the power consumption now is back up to about 1300 or so watts. So you see, with elastic policy, we save power when the system is idle, and when the system becomes busy, when a workload shows up on the system, we quickly go back to the full power state to provide the needed performance. Now I wanted to show you one other capability on the service processor power management capability, and that's the ability to set a power limit. So we're running at about 1300 or so watts, 1350 watts. So let's say we wanted to not let the system use more than say 1250 watts of power. So we might want to do that, for example, when the cost of electricity is high. We just wanted to try to keep the power consumption a little bit lower. So let me set this to 1250 watts. Now the power limit capability only makes use of the processor speed, and the way that it works is the LDOMS manager notices when the power consumption is too high, and it reduces the speed of the processors in order to meet the requested maximum power consumption. Whenever the power consumption goes over, it adjusts these processor speeds in order to reduce the power as needed. So you'll see now, if we go back and look at the power consumption, it's below 1250 watts here. And if we removed the limit, of course, the processor speeds would all go back up. Now I just wanted to show you one other thing. Because we only have this one mechanism for saving power, there's only so much power that can be saved. So if we tried to save more power than the processors are capable of saving, so here I'm trying to reduce the power down to 1100 watts from 1350 or 1380. The LDOMS manager will reduce the processors as much as it can and save some amount of power, but it won't be able to get down to 1100 watts. And the ILOM service processor will notice when the power cannot be reduced down to the requested amount, and if it stays above the requested amount for a certain amount of time, then it will notify you that the power has been exceeded with notification both on this page, and also if you choose you can request that there's an SNMP notification and so forth. So let me just put the limit back to an achievable power consumption amount here. I'll just go back to 1300. And you'll see that the processor speeds will go back up a little bit to just get to the required limit here. And the limit also works if we're in the performance policy. And you see here that once the performance policy is enabled, the memory all goes back to normal, but the processors remain slightly dampened in speed in order to stay below the power consumption limit that was set. Now, if we disable, or rather stop the load, pause the load. Now we're in performance policy, remember, so we pause the load, which of course brings us well below the limit that was set. But because we're in performance policy always keeps all of the hardware resources in full power state unless the limit is exceeded, in which case this processor speed can be reduced. So right now we put the processors back to full speed because we're in performance. Now if we were in elastic policy with the limit set, as you saw, the processors will be reduced just as much as is needed to achieve the limit while the workload is running. But now that the workload's not running, the processor speeds and the memory power modes are set to save power because the system is idle and the performance is not needed. So that's all I really wanted to show you today. In summary, you can use the elastic policy to save power on idle systems, and you can use the power limit to limit or reduce the power on systems running a workload. These same power savings features are also available on the Oracle T3 system. I hope you found this video informative. For more details on how to manage the power savings features, check out our Oracle Technical Network article on T4 power management. It covers more or less the same information that was covered in this demo today.